periodic trends. So this experiment is a worksheet. There is no really videos to watch except for lecture material if needed. What you're going to do is it's a packet. The packet has really clear information, and then in each little section there's questions. So you'll turn in the whole entire thing. Again, still lab category, so write in blue or black ink. Very, very neatly, you write your name, submit to Canvas. So each section has to do with the periodic trends electron configuration. We know that Schrödinger equation helped us determine that there are orbitals where there is a high probability of finding an electron. But there's a little bit more to that, which are quantum numbers. So these 4 quantum numbers are from the Schrödinger equation that was solved, which helps us describe the trajectory and movement of electrons. Electrons have different set of quantum numbers, describing the quantum numbers and their functions. So we have the principal quantum number. This is the shell, right? If we think of the onion, we have our nucleus. Then we have our first layer, our first shell. Then we have our second, our third, etc. So our principal quantum number tells us the size of the atom, because the principal will be the furthest one to the atom. So that's however big it is. If you have n is equal to 3, your atom's going to be bigger than n is equal to 2 or n is equal to 1. The angular momentum quantum number then tells us the shape of the orbital. Do we have an s orbital? Do we have a p orbital, a d, or an f? The magnetic quantum number then tells us exactly which electron orbital we're talking about, and then the magnetic spin quantum number tells us, do we have an electron with a spin up, which is a half arrow facing up, or down. In any orbital, they're always opposite of each other because they're repelling one another. Now the quantum numbers always specify one specific electron in a particular atom. So what you'll do is you'll go through and read the packet, answer the following questions. We have the electron configuration, a little bit more explanation of each part of the different periodic trends and how to have electron configurations, how it splits up, etc. So I'm just scrolling through here so you can see the different examples, and then every time there's practice, those are the questions that you fill out. Now this packet is really, really detailed, and it's going to help you as you continue in chemistry.